Hello.
Hello.
We have today measuring concentration.
Of solutions.
How many different ways do we measure concentration?
Ooh, we can do at least 4.
Yeah. And then there's 4 with calculations and 1 that's qualitative.
Right.
Us looking at things.
Yeah, looking at this, I can tell which one's more concentrated.
For sure. Dilute versus concentrated. Which one of these is dilute, Mr. Mills?
The one that's a little bit closer to the color of your shirt.
And that therefore must be more concentrated.
True that.
Sure.
And this is really impactful because not just because I want my Kool-Aid to be mad sweet, so I make it more concentrated.
Mm-hmm.
The concentration of certain solutions can affect how fast they react.
For sure.
And how much they could actually impact and burn you.
This amount might be good for treating on cuts and bruises and burns to help clean you.
And
but if it's more concentrated,
this one might be good for melting your face off.
Yeah, causing burns.
Yeah,
even though it's the same chemical, the difference in concentration might be what's up. And that's why we showed you 12 molar acid, serious burns, versus 1 molar acid, which we use
might
in our
cause
labs.
an itch.
Yeah, maybe.
Yeah.
Ish. Yeah.
So moving on. Let's get into the heart.
Units.
Yeah. We got to be able to calculate these things. Handy dandy reference table. Molarity is the big one. Capital M, by the way. Capital M. You'll see this. Moles of solute. We get that from unit 4 or 3 moles in stoic.
Yep.
So we're going to bring that back up. Liters of solution. There you go.
Divide them and you got your molarity.
Yeah, that slash here is the way we divide, written in,
If you see here, they're written over and under. If we have typed on our computer here, we have to draw it side by side. But that's math.
Yeah, and it's, Microsoft. So we're doing it. That's molarity. Big one.
The other one that's really useful is parts per million.
Very common.
But it's only used for very dilute solutions because there's not much solute in there.
Right.
So you don't the molarity value would be so small. Let's find a different unit that's a bigger number that's easier to write on paper.
Right. And then we use this actually a lot. You'll see like around Charlotte Beach when we're doing parts per million and parts per billion phosphates in the lake. The phosphates is the food for the algae. If that number gets too high, the algae got a lot of food. The algae got a lot of food. They multiply. The lake's closed. You don't get to go to the beach.
Exactly. So parts per million does have an impact on our life here in Rochester.
Does. And the key piece here is it's not liters of solvent anymore. It's of the actual whole solution now.
For sure.
You'll see that in the calcs.
These last two, percent by mass and percent by volume, they're really just percent compositions.
Yeah, we're just going to substitute in the mass or substitute in volume.
And when we say mass of the part, we're saying mass of the solute.
Yes.
Divided by the mass of the whole, which is mass of the solution.
And it volume's the same way. The part would be the solute, and then the whole thing would be the solution.
Yeah.
Okay.
Full show. So I think we've got some calculations to do.
Yeah, let's do that. To the board, Monaco.
All
right, so both of these equations are on table T for you. We put them in the notes so you have them. And we have now the first one, moles of hydrogen dissolved into 4 liters of water. What is the molarity? So let's label them up. I got 2 moles of solute. I don't got to calculate moles here. It's given to me. I have 4 liters, so I don't have to do any calculations there either. I know that molarity is moles over liters. So it's 2 divided by 4, which is pretty mad easy, mister. I can do that in my head. I have a 0.5 molar solution. Very common. That's a very normal number to see. Okay. The next piece is just kind of doing it backwards. It's algebra, bro. So you can rearrange the equation if you'd like, or you can just plug and chug into the given equation and just use your algebra skills to still solve. But in this case, it gives me my molarity. So the molarity of my solution is 4, and the volume of my solution is 5. So if I plug those numbers in, I got to plug in the 4 for the capital M. And then I don't know the moles. I'm solving for that. And I have to divide by liters. And now to get X by itself, I simply multiply both sides by 5, which means 4 times 5. And I can do that in my head, mister. We got 20 moles. I would need 20 moles of stuff to put into 5 liters to make my solution 4 molar.
At a specific concentration.
And I literally do these things when I'm making up acids and bases.
We both did these at Kodak all the time. They didn't have solutions ready for us, but the recipe said you need this concentration solution out of the raw material. Make it and then use it.
That's right. So it is useful. Okay, next piece. Grams of solute for molarity. So this is the 2-stepper. Okay, this is the real deal. We got to go from grams to moles first.
That's our mole step.
And then we'll do the molarity step like we just did but I was given molarity moles in the first one. So I'm going to start with given mass 33 grams, and my total gram formula mass is 101, given to me in the problem, which is nice. We could calculate that, adding the mass of potassium, the mass of nitrogen, and the mass of 3 oxygens, and come up with that number ourselves, but it was given to us, so let's use it. Okay, I know that I taught you guys to follow your units, starting with grams times, when this grams goes in the denominator now. But see, look, Mr. Monaco is putting grams in the denominator following that formula, so both ways work. Okay, we don't have to always dimensional analysis, but we have, in my class, have done everything dimensional analysis. Style. So now it's 33 divided by 101. Rearranging some electrons, and we find out that we have
0.33 moles.
0.33 moles, perfect. Which is basically divided by almost 100, so it makes sense.
But we're not done.
Can I get, oh yeah, that's just moles though, so that's a little m.
Mm-hmm.
And now we're going to use that in the next step now that I have my moles. So I'm going to take that moles and bring that down into my moles of solute. Okay, I'm keeping my units so I know what's going on. Liters of solution from the problem up top, 10. So now it's 0.33 divided by 10, and I'm good because I can do that in my head also. These are some nice, easy calculations as far as numbers-wise to learn on. I like that I can do it in my head.
Capital M, not lowercase.
Capital M, and notice it is capital M pre-labeled for us, so 0.00033 molar, which is mad dilute, mister.
Yeah, I was going to pop quiz him on that, but the smaller the number, the more dilute.
That's right.
There it
We
is.
could have even probably gone parts per million with something that small.
For sure.
For sure. So speaking of parts per million, let's do 1% mass, and we'll do 1 parts per million just so we all get a hang of this. So this is mass of the solute I need, which is 35. And then the whole solution is the key here. So I need to add the 35 and the mass of the solvent, the water, together to get 1,000 grams. That's a total solution. So now it is 35 divided by 1,000, which again, I can kind of do in my head. And all percents end up multiplying by 100. So divide by 1,000, multiply by 100. Bam, move the decimal there, move the decimal there. We done. 3.5%.
Yeah.
Boom.
Boom.
All right, now, parts per million. This is the one that's a little bit more common that we need to be able to do and look at wee little tiny amounts, not even close to a gram. Okay, so I'm going to take the mass of my solute and then again the mass of my solution. And now this number is going to change ever so slightly, that 200 grams, but not a lot. I challenge you to do the calculation both ways and see what the answer is. I bet you the answer is going to be really close. Okay, but this is the true way to do it. So I'm going to divide it by 2,000 or 200.009, multiply it times 1,000,000. This one, neither of us are doing in our heads. I'm good at math. He's good at math. Whoop, this
Not
is good at
holding
math.
things.
Yeah,
Not good at holding
it's still
things.
got electrons. Use them.
Thanks, Scrap.
I'm not your scrap.
Bro. I'm
Silly.
not your bro.
You funny, mister.
Looking.
Yeah, that's true. That I am. What do we get?
44.99797.
44 point. Yeah. Can we call it 45 between friends? 45 parts per million. Love it.
Very, very tiny. That means if you had $1 million,
You'd have 45.
45 of them would be like colored red or something like that.
Out of 1,000,000.
Out of 1,000,000. That's like almost nothing. It's like, that's why
Relatively
we have
not
to
even
use that
something
calculation.
different. If I were to try to turn 0.009 grams of mercury into moles of mercury and divide it by liters of water, which I can actually get from grams to liters, this number would be so small it wouldn't.
So many decimal
Oh,
places, we have to
it'd
use
be hard to
scientific
write.
notation. So
Right.
there it
This
is.
is the way to do it. And guess what? We are now done with lecture video 5. You got some practice calculations.
Boom.
See ya.
Peace. I can find my clickers.
You got a clicker, man.